Hello, we're going to be talking today about fissure projections. This is another type of drawing that we need to learn. And this right here, what I'm holding, remember this is a molecule, it's 3D, and we learn how to do the Newman projection, which is actually this, right? But now we're going to be doing fissure. So let me get started doing a molecule and just talk about what is a convention. So in fissure projections, you're going to see lines like that. But we're going to explain what that every line means. Say that is A, B, C, D, where A, B, C, and D are different constituents. So the convention for the fissure is that the lines that go horizontal are wedges, so coming towards you. And so here we have B and D. And vertical lines means they are away from your view. So here I have AC. That's the convention. Now, how we get to that point? I'm going to draw now a molecule with one chiral center, and let's look at that projection, what it looks like. So this molecule has two chiral centers. So in here, I'm going to use it later to show fissure and Newman. But right now, let's do just one chiral center. This will be an example of a chiral center. So now my drawing, I'm going to have, say, A, B, and then I'm going to draw my wedge. So remember that the solid lines are in this plane, wedge is going outside the plane towards you. And then here I am going to have constituents C and D. Now let's imagine that I'm going to put a little face here, and let's say, oh, my eye, this is my eye, right? And I am looking at the molecule from that perspective. So if I'm looking from that point of view, I see, notice, A and B are in the plane. But now I have going out, so in the wedge, I have C and D. So this is my view, right? So now, if you were doing the Newman projection of that, looking at that projection, we would do a circle. And if this is your view, you will see, okay, A is here, and you're going to have your view being here, C is going to be here, and D is going to be here. A, B, and you don't draw anything else because B is actually an atom that is behind you. So if we change, let's say, B by a metal group, so in the fissure, then this will be H, fissure now, this is Newman. All right, so this is that. This is what we will see. So, but I'm going now to go back to the drawing that had the A there. So let's redraw that. No, I'm using another. I had a B there. So A, B, and then I'm drawing in the wedge, C and D. And now let's say this was when I did the Newman. Now I'm going to do the fissure following that convention. And again, I'm going to say that I'm looking at that from that perspective. Now, from that perspective, what I'm going to say now is that when I have two things, one in coming towards me, so this is my view, I'm here. So I see C and D coming towards me, and that I'm going to draw in the horizontal lines. So C in my fissure, and D. And then I'm going to draw A and B. Again, this is my view. So towards you, if I am here in the middle, I see both C and D coming towards me, and these are going to be coming in. So that is then the fissure projection for that. Now, fissure projections are very useful when we go in molecules with several chiral centers, and in fact, this is the preferred projection when we do carbohydrates. It's used a lot in biochemistry. So I'm going to draw one example of carbohydrate, which is so sugar is essentially. And so let's erase this a little bit. I'm just going to keep that convention in mind. So remember that In the Fisher conventions, horizontal lines, you think as wedges coming onto you. In vertical lines, you think dashes. So, and we said that learning these projections is very useful coming later if you study biochemistry, for example, and you will use it a lot when we represent molecules with multiple chiral centers, and we use it a lot for sugars. And so let's do this molecule. And this molecule, I'm looking at what I have in my handout here. Let's say that I have an aldehyde, and now OH, and I have H, OH, H, and here I have CH2, OH. And what I see here is a molecule, a type 1 molecular sugar, similar to that. In general, they are polyhydroxy CDOHs, polyhydroxyaldehydes, like that, or ketones. And let's run one more. And just say this has 2 chiral centers. And now I'm going to draw just one more. These are my chiral centers. And later on, we're going to learn how to designate the absolute configuration of those chiral centers. This is just examples of how do we, this is used, and that's another polyhydroxy, and that's aldehyde. The difference here is that now I have 3 chiral centers, CH2OH here. Chiral centers here, here, and here. We're going to continue studying molecules like that. We're going to learn how to determine absolute configurations and how to go from the Western Dutch representation to Newman into Fisher projection and back.